Hey guys, and welcome back to lesson number 2 in the Operations on the Real Numbers course. In our first lesson, we took our initial dive into the real numbers, and we'll continue that today. So let's go deeper. Real numbers, best way to think of them is as the integers and all the numbers in between. So there we go. We see the integers along there pointed out in red and the numbers in between in green. And we saw also that in between is really where all the action is. There are way many more numbers in between the integers than we've got integers themselves. So that's why we're diving in to the in-between spaces. And a big group of numbers that live in between the integers are the fractions. I can't stress this enough again. Fractions are numbers. That's it. Fractions are numbers. Now, just like all the other numbers you've learned, we often use them to represent things in the real world or objects. So let's do that right now with one of these fractions. Let's represent the number 3/4. So we said that that's a number less than 1, and the force tells us that we need to break up this bar into 4 equal pieces and keep 3 of them. That's how we would represent 3/4. Just like you would represent the number 3 to someone by showing them 3 whole candy bars. Okay? We also saw that when you have a number like this, 9/40, well, showing all the lines to break up that shape gets a little bit tiresome. So we came up with this idea of benchmarking. So the 40th piece, the 40th would be right there at the end. Halfway would be the 20th, where the 20th would be. I'm going to go half again because that's where the 10th 40th or the 10th piece would be. And look what we're trying to represent, 9/40. So 9 should be just inside that 10 there. And I'm going to color all the way up to that 9th piece. Looking good? That's benchmarking. We also saw that percents are just a fancy name for hundredths. Okay, they're exactly the same. So 52% is really just, and I'm going to write this down right underneath it, it's really no different than 52 hundredths. So again, if we want to represent that with bars, benchmarking is the name of the game. So there's where the 100th piece would be, there's where the 50th piece would be, and look what we're trying to represent. 52 hundredths, so we're right in the neighborhood. Let's move just a little bit to the right of 50, and there's our 52nd hundredth, the 52nd piece, and we'll shade all the way up to it. Nothing to it, okay? Now we also did a whole bunch of other work, like we went into the real world to say, like if you need you got a cup here, and it's a 1 cup, oddly enough, and you want to fill 2/3 of it, well, that's no different. Okay, you should be able to do that. Just eyeball it and get really close to it. So 3 equal pieces and fill in a square of water. It looks like, there it is, 2/3 of that cup is filled. Looking all right? All right, you guys got this. We also noticed that it's important to know sort of when you got nothing or when you got the whole thing. 0/13 is clearly 0. You know, if you've got 0 of those pieces, you got none of the pieces, then you really have 0 candy bars. And if you have 13/13, well, then you've got the whole thing. That's 1. Making sense? All right. We also talked about this sort of complement thing. What's left? If you've eaten 7/9 of a candy bar, how much do you have left? Well, we can see it very clearly. There's the candy bar divided up into 9 equal pieces, and we start to eat 4, 5, 6, 7. We've eaten 7/9 of that candy bar. You can see what's left, 2/9. Now again, like we mentioned in our previous lesson, that's something you want to also be able to see just with the numbers. Okay, 7/9. So you've taken away 7 out of those 9 pieces. That leaves you 2 left over. 2/9 left over. Okay? All right. Then we sort of pointed out the importance of the number 1/2. Speaking of benchmarks, right? 1/2 is a great benchmark. So 20/42 is less than 1/2. And how could you check that? Well, good. Thank you for yelling that out. Man, guy's enthusiastic. See him over there? Third from the left? No, my left. 20/42 is less than 1/2 because when you're talking 40 seconds, 21 40 seconds is exactly 1/2. How do you figure that out? Yell it out. Nice. Divide 42 by 2 and you get 21. So since 21, it takes 21 40 seconds to get 1/2. 20 40 seconds is definitely less than 1/2. And we also can say that 23 40 seconds is therefore more than 1/2. Looking good? 1/2 is a pretty important sort of reference value. All right. Well, that brings up the idea of comparing the sizes of numbers just in general. And here's a list. So these numbers are correctly ordered. 0 is the smallest, then 2/11ths, 2/9ths, 3/4ths, and then 1 is the biggest. Now, some of these things should make total sense, like right off the bat, just like way beyond obvious. All of the fractions, and 1 for that matter, they're all positive. So they're all greater than 0. So it makes sense that 0 is on our far left. And 1, since those fractions, if you notice, they're all representing less than 1. There we go. 1 is on the far right of our list. So it really just comes down to deciding about the fractions. And I want to point something out to you. Look at the two fractions, the two leftmost fractions, 2/11ths and 2/9ths. They are both less than 1/2. Make sure you can justify that to yourself. Think about the last slide that we just had. Can you see why 2/11ths and 2/9ths they both have to be, less than 1/2? Good, good. Conversely, 3/4ths is greater than 1/2. 3/4ths is more than 1/2. So it makes sense that the two that we have, 2/11ths and 2/9ths, they should be both less than 1/2 and therefore both less than 3/4ths. See how 1/2 allows us to sort of say, okay, you two guys are bigger than 1/2, you come over here. You're less than 1/2, you go over there. Looking good, right? So the boxes are correctly ordered, but how about the two within the box? Well, that's pretty important to talk about. I just want to steal a second to mention something. Notice we have 2/11ths and 2/9ths. So we actually have we're actually keeping the same number of pieces, 2. 2/11ths versus 2/9ths. So what it's really going to come down to is the size of those pieces. It really depends on the denominator. Well, check this out. Here is 2/11ths. There's a candy bar, 11 equal pieces, and 2 are kept, 2 are shaded. Look at 2/9ths. See how 2/9ths is just slightly bigger than 2/11ths? Well, that's because the bigger the denominator, the more pieces we have to break that fraction bar up into, right? So think about sharing something. If you share it with more people, everybody's going to necessarily get a little smaller piece. So 11ths are smaller pieces than 9ths. So therefore 2/11ths is smaller than 2/9ths. All right? Guys, there's one more thing that we need to talk about in terms of fractions today, and that's this issue of equivalent fractions. And we've sort of already seen it in the earlier discussion here. If you notice, sometimes, like for example, here's 4/8. Let me show you 4/8. Okay, 8 equal pieces. We'll keep 4. 4/8, right? 4/8. Let's say you ate 4/8 of a candy bar. Well, you know what? That's really the same. Let me pull some of these pieces away. That's really the same as eating half the candy bar, isn't it? So in other words, what we're just noticing here is that 4/8 is really equal to 1/2. So even though those two fractions look different, they are exactly the same number. Okay? They're just different ways of writing the exact same number. Well, that turns out to be pretty important. So let's ask ourselves, with these equivalent fractions, how does that work? Well, there's sort of two ways that we see these equivalent fractions happening. First one is simplifying, and the other one is the exact opposite, anti-simplifying. All right? So we go between fractions by simplifying them or anti-simplifying them. And that's what we're going to spend the bulk of our time today talking about, okay, in this lesson. So let's do that right now. Let's talk about simplifying. It turns out all you need to know about simplifying fractions is the way to simplify a fraction is to factor out the number 1. All right, I'm going to give you an example of what I mean by that. Let's say we're asked to simplify 10/15. Well, 10/15, if I write that down there, I can factor both 10 and 15, because they share a common factor of 5. 10 is 5 times 2, and 15 is 5 times 3. Well, what I want to draw your attention to right now is the 5 in the numerator and the 5 in the denominator. If I write this slightly differently, 5/5 times 2/3, then all of a sudden, 5/5, we saw this a couple slides back. 5/5 is just the number 1, isn't it? So in other words, I'm really writing 1 times 2/3, and you guys know, of course, 1 times any number is just that number. So 1 times 2/3 is 2/3. So this is what we've got. 10/15 is exactly the same number as 2/3. It just looks different. And the way you get down to this simplest form of that number is you factor out the number 1. And here that number 1 was 5/5. Okay? I want to really emphasize, when you simplify, you get the exact same number that you started with. It just looks different. Okay? Here's another example. Completely simplify 12/18. By the way, the addition of completely just means you want to take out all the unnecessary ones, all the extra ones that are they're kind of like outfits. Okay, so you just want to strip off all the outfits on this number. So you're just looking at that bare naked fraction. Sorry about that. All right, 12/18. Well, let's do the same thing. We do it by factoring. Bear with me. If you've learned other ways like dividing or something like that, those ways work, okay? I can't say that they don't, but I'm going to ask you to take a little bit of a leap of faith with me. The way we factor at the highest levels, the way we simplify at the highest levels is by factoring, not by dividing, okay? So practice this. This will stay with you the rest of your math career. So let's take a look. Anybody want to shout out a common factor between 12 and 18? Just let them rip. Just start screaming at the top of your lungs. I know, don't worry about it. Your parents need to get up anyway. Yes, good. Both those numbers are even, so they both have a factor of 2 in them. Good. So let me write 12 as 2 times 6 and 18 as 2 times 9. Very nice. So here is our 1, okay? So 1 times 6/9 is just 6/9. We don't need to write that 1 that multiplied in. That's unnecessary, all right? Doesn't change the value, just the look. All right, well, 6/9. Are there any other common factors that we can pull out from the numerator and denominator? In other words, is there another 1 in there? Yes. Nice, yes. Man, I didn't see you in here today. How you doing? Good. Okay, so 6/9. 6 and 9 both share a factor of 3, don't they? 3 times 2 and 3 times 3. Here's another 1. 1 times 2/3 is 2/3. And guys, once we get to 2/3, if you notice, there's no common factors between 2 and 3 other than 1, but that's not going to help us write it any simpler. We're done. That 2/3 is the bare naked fraction. That's fully, completely naked and simplified. All right? And again, just want to point out 12/18 is 2/3 and 2/3 is 12/18. Equivalent just means equal but different looking. Okay? 12/18 and 2/3 are equivalent fractions. All right. Now, I don't know if you guys noticed. Yes, you did. All right. All right, good. We could have done this a little quicker, couldn't we? Look at this. We could have taken 12/18 and noticed that 6 is a factor of both 12 and 18. So 12 is 6 times 2, and 18 is 6 times 3. So look at that. There's our 1, and 1 times 2/3 is 2/3. So either way, we get to the same place. Okay, they're both good. One's a little bit quicker, the bottom one. And by the way, it's not a coincidence that 6 is really 2 times 3. So we see both the parts of the 6, both factors of the 6 inside the other two simplifications, the other ones. All right? Excellent job. Very nice. Okay. Here's one more. 60%. So if you want to simplify 60%, let's first of all, let's write it as a fraction. 60%, as you guys know, is 60 hundredths. All right. What can we pull out of there? There's lots of stuff, isn't there? But wait, do you see a really obvious one? Can anybody see a real obvious one in there? A common factor? Good. I thought you might. And if you didn't, that's okay. Now that you're going to hear it, I think this is going to be something really easy to see from going forward. There's a 10 in both of those, right? And it's sort of indicated by the zeros, the 6, 0, and the 0 in the ones place in the denominator. Absolutely. So let's factor it. Let's factor it. So 60 is 10 times 6, and 100 is 10 times 10. Look at that. There was our 1. 1 times 6/10 is 6/10. So 60% is the same as 6/10. The only thing we have to be careful of is that 6/10 completely simplified, or is there another one? Okay, give me some signals. If you think there's another one, give me your agreement. Anybody disagree? Anybody thinking there's no extra one in there? Ooh, I don't see a lot of these. I see mostly this. Okay, both 6 and 10 are even, so we know for sure they're both going to have a factor of 2, right? So 6/10, I'm going to write that 6 as 2 times 3, and the 10 is 2 times 5. There's my 1, and 1 times 3/5 is just 3/5. So in other words, 60% in its simplest form is 3/5. Looking okay? It's very powerful, this factoring out ones. It's very, very long lasting. You're going to be using this throughout all your mathematics. Excellent job. All right, let's go the other way now. Sometimes you want to take a fraction and convert it into something else, not maybe like put outfits on. Maybe that's the analogy, right? Maybe you got a bare naked fraction and it's got to go out somewhere to dinner, and the place likes you to have clothes. So you got to put something on. You have to put a particular outfit on. Man, this analogy is horrible. Yeah, maybe think about it this way. You, I'm sure, wear many different outfits for different things. So you want to change your look. It's the same person, right? When you go out. So this is just putting on a particular outfit. Here's the good news. Just like we simplify by factoring out a 1, we anti-simplify by multiplying a 1 back in. Okay? So there's the statement. To anti-simplify a fraction, you multiply in by 1. Simplify, you factor it out. Anti-simplify, you multiply it in. All right? I'll give you a couple examples here. Let's say you wanted to convert 3/5, which is a fully simplified fraction, by the way. You want to convert it into 20ths. So this fraction has to be wearing its 20ths outfit. Okay, I'm not sure where it's going, but that's what he needs to wear. Okay, black tie or whatever. So 3/5, we want to take it and we want to convert it, but we want to keep it the same. And that's the crucial part. We want to write it with a denominator of 20, We want to be 20th, but we need to do it so it preserves the number itself. So does anybody see what form of 1 we should multiply by? Look at those denominators. What would I have to do? What would I have to multiply 5 by to get 20? 4, right? I'd need to multiply it by 4. Well, that tells me then that in the denominator, I better be multiplying by 4. But guys, if we're going to multiply by 1, then what's the numerator got to be of that fraction? 4. 4/4. That's the beauty of the number 1. It's got so many different looks, right? It can be 4/4, it can be 10/10, it can be 100 hundredths, whatever you need. You can pick the right form and that'll get you where you want to go. Because look at this, 5 times 4 is 20 and 3 times 4 in the numerator is 12. So 3/5, all dressed up in its 20th outfit, is 12 20ths. Same number, different look. Okay? All right. Since we're talking about these things, let's just do this real quick. Percents are such a big part of everyday life in the real world. So I think it'll be helpful if we can know famous fractions, 1/2, 1/4, 3/4, those nice benchmarks that we've been using in all our applications and representations. Let's convert them into their percent outfits, okay? Well, 1/4, if we want to convert it into percents, you guys know what that means. That means we want to convert it into hundredths, right? Percent just means hundredths. All right, well, what's the 1? What's the form of 1? Show me the 1-y. Okay, that's a movie reference from way back. 1/4 times what form of 1? And again, you can check out those denominators, just like the last one. What times 4 gives you 100? Nice. 25. 25 it is. So 4 times 25 in the denominator. There we get our 100. 1 times 25, 25 hundredths. And if we want to write it as a percentage, as a percent, 25%. So 1/4 is really 25%. You should know those interchangeably, going back and forth as you need. Okay? 1/2, same thing. Tell you what, I've been talking long enough. Pause the video and just write down, and you can show the 1 that you use. Show the conversion from 1/2 and 3/4 into percents, and I'll meet you back when you're done. Okay, let's see. So 1/2, I was listening while you guys were working, and I heard you say 50/50ths is the one you would need, right, to go from a denominator of 2 to a denominator of 100. So 1 times 50 is 50. And you know what? 1/2 is 50%. Half is 50%. That's really super famous, right? That's one you want to know just at your fingertips. Then 3/4. What'd you guys come up with? Beautiful. 3/4. You know what? It's the same form of 1 that we used with 1/4, isn't it? Because we're still aiming at that denominator of 100. So 3 times 25 is 75. So 3/4 is really 75%. By the way, 4/4, we don't even need to write that down, do we? It has to be the same as 100 hundredths or 100%. There you go. All right, very nice. Real quick, now that we know that, is 29%, is that less than or greater than 1/4? How could you tell? Is it helpful to have them in the same form? Well, we know that 1/4 is 25%, isn't it? So now look how easy that is to compare. 25% versus 29%. 29% is definitely bigger than 25%. So in other words, 29% is definitely greater than 1/4. Okay? So it's nice to be able to be really fluid with the different forms, and maybe you don't even need to convert. Okay. All right. Here's our final thing for today. The last example kind of shows that sometimes it's really helpful to have your fractions be the same things. Like instead of 29% and 1/4, we made it 29%, 29 hundredths, and 25 hundredths. And that made comparing super easy, didn't it? Really, really easy. So for example, let's say you had these two fractions. And by the way, both of these are completely simplified. 2/3 is buck naked, and so is 5/7, no extra clothes on them. Let's say you wanted to compare them. It would be, by the way, both of those numbers are bigger than 1/2, so we can't use that obvious comparison. They don't have the same numerators, like 2/9 and 2/11, like that problem earlier today. So this is not obvious. This is not obvious. So what we should do is make them the same things. Let's convert them so they're the same things. And that's going to be done by getting a common denominator. The denominator really tells you the name of the things. That's actually what denominator means. So let's do that. Let's convert them. So if we bring them over here to the other side, 2/3 and 5/7. What's an automatic way to get a common denominator? Sometimes it can be hard to figure out other things like lowest common denominator. I don't know if you guys have heard that phrase before, but you know what? If you just need a common denominator and you need it now, need it automatically, you can worry about getting a better one at some other point. You can always just multiply the two denominators together. 3 and 7 multiplied together give you 21. So you know what? I'm going to use that as the target common denominator. Okay? Well, now it's time to decide what the right form of 1 is. What are we going to multiply in? We're anti-simplifying, so we need to multiply in by a 1. And hopefully you can see, to do 2/3, to convert thirds into 21sts, you need a 7 in that denominator, and therefore you need it in the top too, because that makes the 1. 7/7 is 1. 2 times 7 is 14. So 14 21sts. Excuse me, I forgot my equal signs. 5/7, what form of 1? Nice. 3/3. 3/3. The number 1. 7 times 3 is still 21. 5 times 3 is 15. You know what? Take a look at those two anti-simplified versions of the fractions. 14 21st and 15 21st. You can see why it was pretty hard to tell who was bigger. Look how close they are. They're only 1/21st apart. That's very, very small. So the common denominators lets us figure out very easily which one of those is bigger. Okay? So if it's not an obvious comparison, less than a half, bigger than a half, or same numerators, and then you just have to figure out the size of the pieces. If it's not obvious, you can always get a common denominator, and that makes it like the most obvious of all comparisons. All right? So I think we're in good shape. Excellent, excellent work today. In our next lesson, we'll wrap up our discussion of fractions, and that should set us up nicely to then fully grasp the real numbers in their entirety. I'll see you in the next lesson. Take care.